All right. I'm at a bit of disadvantage. I have to plug my headset in because I forgot to plug it in this morning. So I'm plugged in behind me, so I'm kind of choking myself here. All right. So today we're going to talk about inner and outer joins. I've got just a couple of quick code examples, but I do want to spend the majority of the day building a database. So we're going to go over this code real quick, and then we're going to jump into designing a database. And there's only three pieces of code I'm going to show you today because inner and outer joins, we talked about inner joins last week. So here is where's my use Sakilla? Use Sakilla. There we are. Okay. So last we talked about the inner joins. This is okay, so that's what this is.
That's the
So
full cross join, isn't it? Or the full join when you do the union, right?
yeah. So this is a full join. Well, it's not really remember the unions just take two result sets and put them together.
Okay.
It as all it cares about is that the column count is the same.
Okay.
Because here I've got this one, select last name, first name from actor, where last name like RM from customer, last name
Oh,
like
yeah.
RM.
So that's where if that's you'd have to do like a full outer and a full a left and
Right.
a right to do the union. Okay, yeah, yeah. I'm sorry, I messed that up. Okay, you're right.
Yeah. What is unknown database Sakilla? Oh,
You have two
only one.
L's.
Yeah. All right, there we are. All right, there we go. So do this. Yeah, so the unions are fine because they'll do this thing, and now I've got it to where um there's all here. But remember with unions, I can change that first name and change it to email address and it'll still work because unions don't care. The unions just say, here's two sets, I'm joining them together. Figure it out, it works for you.
Okay.
Then we got our inner join, like we said last week. Last name is actor. Last name is customer. From actor, I'm inner joining customer. Now, the reason I'm doing it this way is because last week, whenever you do an inner join, you're supposed to do it on a column that's indexed or foreign keyed. So indexed, you know what indexes are. So sometime in the next couple weeks, I'm going to go into a deep dive on indexes because I love talking about them. But for right now, an index is just the way that database looks things up. It's like an index in a book. One day I'm not going to be able to say that anymore, but it's like an index in a book.
I know what a book is.
Yes, I'm good.
I'm
Whew.
closer to 50 than I am 40, so
I'm 50 is in the rearview mirror for me, so not by much, but it's still there. Um, so what a foreign key is, and we're going to show that today when I design the database. If I have a column in a table foreign keyed to another table, that means that I've got the foreign key and the recipient of the foreign key. So whatever column is foreign keyed to the original table, no data can be put into that table without it existing in the original table.
yeah.
It's a data integrity thing. It's super important. It makes you really unhappy when you're trying to put data in, but it's super critical to have. And if you're going to do an inner join, the smart money is to do it on a column that's foreign keyed because you know there's not going to be any nulls. You know the data is going to be there and everything's going to be fine. However, you do not have to join on a foreign key. You do it any column. As long as the data types are the same, you can join on that column. So here I've got select last name as
If
actor.
it's not a foreign key, does it do R bar?
It does R bar. So here's the thing about R bar. Um, Even if you have indexes on it, if your table is less than 25,000 rows, it does R bar anyway.
Okay, because it's just that fast and that small of a
Yeah,
memory thing.
yeah. Yeah, so I think in MySQL it's 25,000. I think in like Microsoft SQL Server and in Oracle it's like 100,000 rows. Because it's funny when you talk to people about the size of their tables and databases. I was talking to a couple weeks ago this guy who wanted to bring his database over into our systems, and he called me. I'm like, "Is your database big?" He was like, "Yeah, it's huge." I'm like, "How big is it?" He's like 500 gig. I'm like, that's not that's not big. That's not big. 500 gig, that's medium on the small side. Our biggest database right now is 450 terabytes, something like that.
Whew.
And then we got a bunch about that. We got a bunch that size. So, um, and so like a large table in MySQL, large tables about 25,000 rows. In the larger, more robust engines like SQL or Oracle, you're looking at 100, 150,000 rows is what's considered a small table.
Well, but
And
on those servers, don't they usually have minimum hardware requirements to support that kind of database?
um, yes, yes. But the funny thing about minimum hardware requirements, um, they don't necessarily work that well. But I will say that in many cases, if you tune a database properly, um, you can run on fairly low end resources. But it's all a question of having a database tuned, hit the right indexes there, using the right data types. I haven't even gotten to my lecture on data types yet. We might do that today as I'm designing tables. Um, but yeah, so there's ways to, your minimum requirement for Microsoft SQL Server is like 1 CPU,
Yeah, 1 gigabyte of
like
RAM.
1 GB RAM. I mean, and you can run it on that. But generally speaking, you want to. I don't think I ever have a server with less than 4 CPUs and 64 gigs of RAM.
Yeah, I think if you do that's SQLite. If you do SQL Standard, I think you're right. I think it's like 4 CPU and like
Yeah,
4 gigs of RAM or something
yeah,
crazy.
yeah,
The
yeah,
data
yeah,
center edition, it's like 16 CPUs and 32 gigs of RAM.
yeah, and yeah, data, and then the enterprise is the big boy, and that one's about that size too. And then developer is an interesting one. So Microsoft SQL Server Developer is Microsoft SQL Server Enterprise,
Yeah.
but it's free
Yep.
and it can go on your laptop.
Yep.
But anyway, but yeah,
But but the
so
end
yeah,
user license agreement says you're not supposed to use it for production. So
yes, they will come after you. They will. Oh, I've seen people use it in production and they do not. They're not nice to them. I warn people all the time about using it. You can't even be production adjacent. It's got to be like so separated from out. But yeah, they will hurt you bad for that. All right.
all
So
right.
here in this query, I'm using last name, and you would never foreign key on something like last name because foreign key is by default an index, and indexes must be unique. So I'm using a foreign key just to show that you can, and it runs just fine. I've got my aliases here. I've got my customer. I'm calling the columns customer and actor just for clarity's sake to make the output better. I'm ordering by last name. I'm doing this. So let me show you this too. So if I take away this here, I'll do this. See here. So we were talking yesterday why we do the alias thing. So if I take away the A dot here and last name and the C dot here and last name,
Yeah, you'll get an error message.
yeah, it's one of the
Ambiguous, whatever.
ambiguous column. Yep, last name in the field list is ambiguous.
Yeah.
For the most part, it used to be in the early days of database engine in the Microsoft SQL Server 6 in 2000, the error messages were horrible. In Oracle, the error messages are horrible. Like you'll get something that's like error 1463. And when you look it up, it doesn't mean anything. It just means something went wrong and they don't know what it is. And if you call Oracle about it, they're like, well, we don't know. But lately, in the last 10 years, the errors have become pretty obvious what they are. So if you're running your code to write your database and you get an error, just look what that is, and it'll tell you last name ambiguous. You go, oh, look, I forgot my qualifiers here. So let me put my A dot here again and my C dot. Okay. So here, um, and I'm gonna do here again. I'm joining on an undexed column just to show you what happens here. So I'm getting my last name as actor and last name as customer from actor and customer. I'm joining them on a left join. So this is the left table and this is the right table for all intents and purposes. So what's going to happen when you do a left join It returns everything in the left table and only the things that match in the right table. And if there's something that doesn't match, it gets a null. So when I run this, you'll see all these nulls.
And that's because you specifically highlighted the that type of join. Because
Yep,
if you
this is the
do a
left join.
normal, if you do an inner join, those nulls don't show up, right?
Correct. So what'll happen is, look at here. So I've got this join here. I've got Ackroyd, Allen, and Astaire, and Bacall and Bailey, right?
Hmm.
So that means in the left table, there's in actor, I've got Ackroyd, I've got Allen, I've got Astaire, Bacall, and Bailey. In the customer table, all I have is Allen and Bailey. Okay. So if I run the inner join,
You're only going to get, that's
Allen
right.
and Bailey.
Venn diagram, you only get the overlap, whereas this one
Correct.
forces every. Okay, yeah, yeah.
So this gives me everything in the left table and only the things that, so I know that there's an Allen in that table. I know there's a Bailey in that one. Okay. The right joins is the exact opposite. All I did this query is I just changed this to a left to a right. So now it's going to return everything in customer and only the things that match in actor. So here,
Be the other way around, yeah.
yep. So I've got here's Allen, but here's Abney, Adams, Alexander, Allard, Allen, blah, blah, blah. So that's right. So again, there are uses to these because if this is mostly, I use them mostly just compare tables. Like if I have two customer tables from two different companies, I want to compare them. I would do that to see what's miss, what's what I if I want to see what customers are unique to each table, I would do this. I can't full join does not exist, but if I do this,
Union all.
I get a full join. And this is what a full join is just everything returns and nulls where it doesn't match. So I run this and oh, it doesn't like that. Why not? Give us a
Jackson, man, Chris one.
copy message.
Is it because you have the order by on the first one instead of the second one, or?
Oh, it won't actually won't let me. It won't let me do a union. Oh, it's this order by. I think that's what it is. I think you're right. It's the order by. There. Yeah. So here we go. With this one, I've got Ackroyd, Allen, Astaire, Bacall, Bailey, and I've got nulls on both sides. When I get down here, the nulls are on both sides. So this is what a full join does. If I do union all, it'd be more interesting. If I run that. Yeah, so here we are. And if I order it by last name here, I can't really order by a last name because it's just going to do everything here. So here I've got nulls here, and then I go down here. I got nulls on the other side. So that's what a full join is. Never really understood the purpose of the full joint. I'm disconnecting if my battery lives for the next 25 minutes. Does I need more flexibility for what I'm about to do? Okay, so that's what a full join does.
Okay.
And again, so outer joins are generally used to compare two tables to see what one table has, what one table doesn't have. Um, and basically, when you're in this field, you just have a toolbox full of tools, and you just got to figure out which one's the best one to use. I've been on job interviews and I've given job interviews for people saying, "Hey, do this in code." I remember one job interview specifically I went to. It was oddly enough for the Golf Channel. I don't know why I was well, because it was for Universal Studios, and I wouldn't mind working for Universal Studios, but I didn't know it was specifically the Golf Channel. And it was funny. I walked into the office for my interview, and if when I was in the office, if you saw my desk, I had like Superman stuff and Green Lantern stuff and Doctor Who stuff. I had all the sci-fi nonsense and stuff on my desk. And I walked into this place and everyone has like golf tees and golf clubs and golf balls and golf posters and golf calendars and golf shoes. And I'm like, I don't belong here. This is not the place for me. But I did the interview anyway because I was looking for a new job. And they asked me to write code, and I did. And then they questioned how I wrote the code. I'm like, you didn't ask that. You did. I forget what they did. I just did. I wrote the code in a fast and dirty way. And like, well, why wouldn't you use this command? I said, you didn't say that. You said write the code. If you want something specific, tell me something specific. I'll write to what you want. But if you say do this, and we're in a 35-minute interview, I'm going to write it fast and get the job done.
Yeah.
I didn't take that job. I actually had a long conversation with HR about how they handled that interview. Anywho, so that's pretty. So this week is just really about inner and outer joins. We did the code last week. We did the code this week. Um, so what I want to do now, if it's okay with you, Mark, since you're the only one here, I'm going to go ahead and I'm going to open up the model, and we're going to talk about how to design a database.
Make a new database cool.
Yep, yep, yep. Okay, so
A diagram.
I go in here and open the diagram, and I've got my tools on the side here. This gives me a new table. This gives me a new view. This gives me a new routine. So right now we're not going to do anything other than tables here. Okay. So let me see. What's our database going to be? Let's do what database do we want to make today? Let's rehash the one I like doing the one about. I'm going to do a database that tracks um space launches from NASA. All right. So if I'm going to do this, my first table, let's see. I'm just going to map out some tables here real quick. I'm going to make a table. Um, my first table is we need astronauts, so I'm going to make an astronaut table. And then I'm going to make a mission table. Okay. And I'm going to make a spaceship table. I'll do a module table. Our module table. Okay. And then I would make a launch site table. Notice how all the tables are not pluralized, not launch sites, it's just launch site. All right, and then let's just start from there. All right, so astronaut. First, we're gonna have an astronaut ID, and I'm gonna make that data type int. So this is where I start talking about data types. Um, Data types are surprisingly important in your database creation. Okay, because every column in your table takes up space on your hard drive. And it's important to be able to control that space because your database can get awfully large because you made a bad choice in data types. Notepad. Notepad. Okay. Okay. So, that was weird. Notepad. Okay. Okay. Um, so there are two. There's fixed length data types and there's variable length data types. When we're looking at numbers, like here, so we're at go back here. So here, the question is, what data type should I do for my ID? So in that I've got tiny int, I've got small int, I've got int, and I've got big int. I think that's it. Is that the four? Let me see. Let me see. Int. Okay, that's my standard ones. Int, medium. Oh, there's medium int. Okay, and tiny int. There's also big int. Okay, so I'm gonna I'm gonna do the data types that exist in Oracle and Microsoft. So tiny int is negative 256 to positive 256. Small int is I'm gonna roughly make out these numbers. It's something like 52,000, negative 52,000. Don't quote me on the numbers. Just get the idea of what I'm talking about here. To positive 52,000. Int is something like negative 2.5 million to positive 2.5 million. And then big int is just like 60 kajillion. It's just huge. It's just giant. I forget what the limit is, but it's a number that you're never going to reach in your lifetime. Okay. Now with each of these comes a size. This is 8-bit. This is 16-bit. This is 32-bit. And this one is 64-bit. Okay. So what that means is if I have a column that is tiny int, every row in that table that has that column is going to take up 8 bits of space, regardless, not bytes, bits, regardless of what's in there. So if there's nothing in there, it takes up 8 bits of space. If the number 1 is in there, it takes up 8 bits. Number 256 in there, it takes up 8 bits of space. And if I try to put a number that's too large for that data type into the column, I'm going to get an overflow error, which kind of makes sense because it's too big, right? So small int does 16 bits, int does 32 bits, and big int does 64 bits. Now, why is this important? You think you're saying to yourself, this is important, Don. This doesn't make a difference. Who cares? Okay. If I have a table that's got 2 million rows, 64 to 32 makes a huge difference. That column is twice the size in there. And if it's 2 million rows, it's your column is taking up space in the gigs because of how many you have and the size of it. Okay. So it's very, very important when you start a database to understand how big you think it's going to get and use the proper data type in the column so you don't have to go back and change it. Because you can. If I started this table out as tiny int, right? Oh, there's big int. I started out as tiny int. Where's tiny int? Where are you, tiny int? There. Okay. And all of a sudden I hit row 257, right? I'm gonna get an overflow error. And I can go back in and change the table to do int or whatever medium int or whatever int I want to do. But it's gonna go R bar through the table and increase the size of that column in each row one after the other. So imagine how long that would take in a table that's 257 rows long. Now imagine how much the space that would take in a table that's 2.4 million rows long. When I worked for a company called Property Insight, their database had operating for about 10 years. And I think I told you about them before. They were a title insurance company, and they would research records. They would do deed research across the country. We had Arizona, all the states sent us their stuff. So we had a bunch of little databases for each state, but we had one big database for our transactions, the searches. And when they made the search table, they made the ID column int. because at the time they didn't think they'd reach 2.5 million rows in a very fast time. Flash forward a couple of years later, they were getting close to 2.5 million rows, and if they didn't change that, the table would stop working. The application stopped working because it couldn't record anything more to that table. So we had to take a 4-day outage to change this. Because we couldn't have anything running against the database while this was going because we couldn't have any rows added.
Yeah.
And we had a couple different ways we were going to do this, but because of the way the database was created and all the guy who designed it and whatever drugs he was on and all the foreign keys and the indexes and all the nonsense that was going on, the only thing we could do was run the command to change the data type from int to big int. It took the better part of 3.5 days to run because the table was 2,450,000 rows. And what happened was, so again, every row, that column was using 32-bit, and then it was using 64. So that size of that table grew significantly over those 3 days. And that's what took so long because we had to manually grow the database, and then we ran out of space, and we had to add new drives. So they didn't understand, even though I tried to explain to them, that this database was going to grow significantly. And when we did the test runs on it, um, they were not happy that it was going to take a 3-day outage. Ended up being 4 days. But that's what it is. That's why when you do these databases, when you design it for real, it is so very important that you choose the correct data type. Because if not, you'll paint yourself into that corner, and then 3 or 4 years, you're taking a 3-day outage to increase your data size, and that costs time, money, downtime. I mean, I think the overall cost of that at that point, that was in 2007 that happened. I think they calculated the cost of the downtime to be somewhere around 15 to 25 million dollars because downtime we had to buy new hardware for it. I was on the clock for 3 days straight to watch this thing because I had to babysit it because if it failed, I'd have to pick it back up. Um, so when you're doing these things, it is super critical to choose the right data type. Um, any of your number ones are fixed width. So your all your number ones, you got your floats, your multi-point, your geometry, your timestamp, all these date, time, date, they're all fixed width. They don't change. Decimal, double, float, medium, int, real, all of these things. Bit is one. Bit is one on or off. It's 0, 1. So if I'm doing so I go here, I'm doing my astronaut table. Um, in the lifetime of my database, am I gonna have 2.5 million astronauts? Probably not. So I'd probably choose not int, but I'd probably do small int as my it always does is when I try to use small int. Yeah, whatever. Yeah, I would
Is
change
it
that to
asking
something
you
else.
for some format? Because it has the parentheses, like it's asking for a format. Do you have to set the lower and upper limits?
No, that should be by default. That there shouldn't be. There it is. It's because it didn't want the parentheses. I didn't want to give it the parentheses. So that small int is going to be like the 52,000 mark. So that's about right. I'll probably in the lifetime. I don't think there have been 52. Alexa, oh, you're not working. Let's see. How many astronauts, U.S. astronauts have there been? Just Kenya, that's fine. Okay, you're going to be weird. I don't want to deal with you right now. Okay. AI is being weird. Anyway, so Smollen's probably gonna do it. Okay, so let's see. Let's go to astronaut last name. Now with last name, it does this varchar. So you got two choices with text based that you can use. There's other ones and you shouldn't use them. So you basically have char and you have varchar. Okay. Char always has a number and varchar always has a number. Okay. And that's basically how many characters you anticipate to be in that column. The difference between char and varchar is if you choose char, it will request a space 34 for 34 characters every single time, no matter what's in there. If there's nothing in there, it's 34 characters big. If there's one character, it's 34. It's always 34 characters. If you choose varchar, um, it's whatever it needs to be. So if you choose varchar 34, if you get one character that, it only takes up one character space, but it can take up to 34 characters. Okay. Um, you have a choice called varchar max, which means it puts in as much as you can. Um, Boy, I want to get into that right now, but I'm not going to. Don't ever use this. Don't ever use text. Don't ever use this. Don't ever use image. Um, don't ever use this. Those three screw up your database indexing something horrific. Um, they are bad. As a matter of fact, text and image are supposed to be redacted in almost every modern database system, but when they say redacted, it just means it's there. We just don't encourage you using it. So I'm gonna get into this. Okay, so one row. So when you're looking at a table, right, you've got the row of so the rows, all the columns. That can't exceed 128K. One row, 64K. Okay. It can't exceed 64K. Everything that's in there, because if not, it fragments and it goes in different places. Okay. So if you have a text, right, and you put text into a line, a row of data, and that row of data is now 6,000K, right? It only holds 64. So that 6,000K gets put in another location in a text field, and it's still linked to the original location on the drive, and it's all messed up when you try to defragment. Um, I'm going to give a real bad. I don't want to this. I don't want to dive into this because it's going to explain things. If you use varchar max and you exceed the 64K, what happens is the database engine has another very specific place set aside to put data in. Okay, so what happens in text is it crams all 600K into that drive space that's allocated for that database, and it blows the whole thing up. It messes the entire thing up, it screws it up. If for varchar max, what happens is it puts in whatever is allowed by the 64K, and the rest is placed in a different location with a pointer to it. So it's not stored in the actual table. It's stored in an alternate location, but there's a point director to go and get it. So it doesn't damage the indexes. It doesn't damage the fragmentation. It doesn't do anything. It's over here if you need it. Go get it if you need it. I promise you a much deeper dive into this at a later time when I start talking about pages and extents and fragmentation and all this other nonsense. I love talking about it. We will talk about it.
Is that what they call a spillover table?
So yeah, yeah.
Okay.
Text, image, and blob are spillover columns, and it just messes everything up. Varchar Max fixed that problem. And I'll go into greater detail on how it happens later, but for right now, just you want to use this.
Okay.
Don't ever use these. Matter of fact, it took me when I was at Property Insight, it took me the better part of a year to take these out because these were all being used in there. There's also a new one, this. Don't ever put that in your database. Don't make an XML column. Um, Microsoft put one in Windows in SQL Server 2008. Microsoft put an XML data type into SQL, and when I was at Property Insight, they convinced us to create a column using an XML data type. So XML is a markup language that creates a database in hypertext. So you can create. So what happened was you created a database within a database in that column, which was unindexable. You couldn't search it. It was a nightmare. Microsoft doesn't do that anymore. So these four, don't ever use them. Anyway, back to here. So varchar last name. So we have varchar first name. Varchar 45, sure. Actually, probably last name is probably you might have like Rabinowitz or something like that. So you might do like 200, some ridiculous long Russian last name.
Welsh
Um,
last name.
yeah, yeah, yeah. First name, last name. We're gonna do date of birth. We'll do date of birth, and that would be that is date, not date time. I just want date. There we are. Okay. Where'd you go, date? There. Okay. Then we're gonna do military. Military rank. And then that'll be varchar, and then we'll do address. What else are we put in here? We're gonna do mission. We'll do rank. We'll do crew assignment. Okay. We'll just leave it there. Okay, so we've got error. Okay. So I've got astronaut ID, last name, first name, date of birth, military rank, address, mission, and crew assignment. Okay. These are fine. Varchar 45, probably want Varchar 300 on that one. Okay, and then mission, crew assignment. Okay, so now, um, I look at this, and this is what I'll do is I'll just start snowballing ideas at what columns are in here, and then I'll look at what I did, and I would not put military rank in in the astronaut table. Any guesses as to why I would not do that?
Well, you have different ranks from different military branches, and that probably should be like a. You can have the same rank in multiple branches, so you probably should have another table for that.
Okay, that's one reason. So one reason why we put things, so there's two reasons why we put things on other tables. Number one is because I want to make sure that I've got data integrity and I don't have people typing in things that don't exist. Like I misspelled military 17 times there. I fixed it, right? But to your point, you're almost there. So I've got many different ranks in the Air Force, Marine, Army, blah blah blah, right? But can one astronaut have more than one rank?
I'm guessing not. Well, they throughout their lifetime they can,
Yeah.
yes.
So if I got an astronaut who comes in as a, forgive me, I don't know my ranks, a corporal, and then becomes a general, right? I don't know if he's still be flying missions, but if he comes in at 28 years old as a corporal and then starts going up the ranks over time, his rank he'll have more than one rank designated in here, and I'll want a historical record of what ranks he had during what mission. So I can say, like, Bob's first mission, he was a corporal, and his 14th mission, he was a general, right? So one astronaut could theoretically have multiple ranks over the time of his career.
Mm.
And one rank would have multiple astronauts in it, right? So this becomes a many to many. So I would create a rank table. So I would call it military rank. Oh, I hate you so much. Okay, there we are. Military rank. Military. Wow, I'm Sparble had set rank. Okay. We'll just forgive Don's typing tonight. Okay, so I'm gonna have a military rank ID. I'm gonna have a not division, um branch.
Branch. Yeah.
Yeah. And then I'm gonna have rank. RNCH, and then I'm gonna have rank. Okay, now here is where I'm this is good. This can work out really well. I will about to show you the number one mistake that people make in doing databases every time. So I've got a military rank table, I've got branch, and I've got rank. Now, if I keep the table this way and I need to input data into this table, I need the end user to type in the name of the branch and type in the rank, which leads to human error. Or they can like invent a new branch. So I don't want to do that. So what I'm going to do is I'm actually going to create a table called military branch. Okay, I'm gonna call this military branch. Military branch. Now, I am going to do the military branch ID, and then I'm going to do a Army column. I'm going to do a Navy column. I'm going to do, spell it right. My goodness gracious me. It is 10:25. I'm going to do an Air Force column, and I'm going to do a Marines column. Marenes. It's wrong, but it's going to go for right now because it's 10:30. And do Coast Guard. Now, this is how not to do that table. And inevitably, the people who don't watch this video, who are doing this project, are going to make a table that looks like this because they're going to say, hey, I've got a table that's going to have a bunch of different things. I'm going to put a column for each of them. And that way I can link it to here. But the problem is I can't link it to here. I can't say Army branch because this is not a valid way to link these two. I can't connect the Army table to the branch. The Army. So the other problem with this, and the bigger problem with this, is we never want to design a table that if something changes, that we have to change the schema of the table. I never want to have to add a column because that takes time, effort, causes problems. Imagine if imagine if I had a table that was like 2.5 million rows and I need to add a column. Again, 2 or 3 days downtime, doubling the space of the database. Okay, so now I do military branch. I do this. I can't connect these tables because I don't have a column to connect to. Because military branch ID is going to be one is going to have all three of these. I'm going to have a checkbox. It's not going to be one Army, two Navy, three Air Force, four Marines, five Coast Guard.
So is this where you
All
do an enum field?
no, this all I do here is I do name, branch name.
Branch name, and then you just
That's
leave
it.
it like a bar chart. You don't do like a fixed drop down or anything.
Nope. That comes into the front end. The front end does that, right? So I just get rid of all these columns here. Now I have military branch ID and then branch name. And so when I pull a drop down, one will be Army, two will be Air Force, three will be Marines, four will be Coast Guard, five will be Navy. But also, we now have Space Force.
Yeah.
So I need to add Space Forces. So all I've got to do is add a line to the table. So what I do here now is I go to my
Schema
military
doesn't need to
branch.
be changed. Okay, I see. Yeah.
Yeah. So here, if they add another branch to the military, I just add another row. I don't add another column. So if they add a deep sea force, or they add a I don't know, whatever it is, whatever they do, interstellar force, they do the Federation. Um, all we do is add another row in the table, and it's there on the drop down list. Everything is clean. I'm not changing the schema. It's not causing problems across the board. But what I'm going to do here is I'm going to get rid of this branch column.
And then you're going to do a link between them. Okay.
Yep. I'm going to cut that, and then I'm going to do a one-to-one. And that should have added, nope, I did it the wrong way. Do my one-to-one. Nope, did it the wrong way again. There we are. So now I've got my military rank. I've got my branch ID that links over to here. So now I'm going to do a many-to-many between my astronaut table. I'm going to grab this guy here. Grab my many-to-many. And it does this for me. So now my military branch is gone with my military rank. And then my astronaut and my military rank are joined, and my astronaut has military rank. And what I'm going to do here is I'm going to add a column to this table.
For a date.
I'm going to do data service. Dates of service. Or however they would designate it. So I know when he was start date, end date. So I can see when an end date. And just change these to date. Now I want you to notice something here. No, I know. I'm sorry, I forgot the E. Date. There we are. Okay. Now I want you to notice something. Here, when I made this table, I got one little thing there. I got my little, that's my primary key.
Yeah.
There's my primary key. There's my primary key. But here,
Those are foreign keys.
they're primary keys.
Oh. Because you have to have
Because
both, because it's depend. Okay, yeah. It's a linking table.
so a table can have multiple columns in the primary key, as long as those columns will never have duplicate values. Okay. I could absolutely put an ID column here that doesn't use those two, but I can just use this instead. It works just as well. Okay. So now here, and this is the way this works now, I can find out how many astronauts had a specific rank. I can find out how many astronauts are in a specific branch of the military. I can find out what people's ranks were at a specific time. So all of a sudden, I can write multiple queries off of this. Okay. So this can go, the military rank can go here now because that is no longer needed. Delete. Okay. So address, that goes there. Mission. One astronaut will go on many missions. So one mission will have many astronauts. So this is another many-to-many relationship. So go to my mission table. I'll do mission ID. That'll be an int. I'll do this will be interesting. So the mission would be launch date. Then it'll be then we have
Don't they have like a
landing
code name for the missions?
landing sure, yeah, landing date. Oh yeah, thank you for the name because everything have a name. Okay, and then we'll have a launch date. And then a launch time. And then a landing date. And a landing time. and then destination, and then a number of days, and then I know I'm not going to put astronaut here because we're going to have a table because one mission has many astronaut, one astronaut goes on many missions. We'll do launch location.
Wouldn't that go on the launch site table that you have?
We're gonna get to that in a second. I'm just doing this out so I can demo how we fuss this stuff out, right? Launch location, and I'm about to change that launch site table to something else. And then I have landing location. But you're on the right track. Okay, so mission ID, name, launch date, launch time, everything belong destination, destination. Um, a mission will only ever have one destination. We're not going to do multiple places, right? However, again, it's one of those things where I don't want people getting creative and typing in things that aren't supposed to be there. So I want to make sure I control that. So I'm going to do a destination table, right? And destination ID, and then the name of the destination. Okay, and then I'm going to go here and get rid of this column. And then I'm going to bring that over here. So I got that destination ID over here. Now, to your point, launch location and landing location, there'll only ever be one. However, I don't want to let people get creative. So I have a launch site here, but I'm going to change this table just to locations or location because I can have all that in one place, just the various locations. And I'll have a location ID, location name. And then I can do launch site, and I'll do this as a bit.
Ah, like yes or no binary.
Yep.
Yep.
And then landing site and do that as a bit. And that's okay because they're going to be launch sites or landing sites. They could be both. They could be one or the other, right? Like Cape Canaveral, thanks to Elon Musk, is both a launch site and a landing site for the things, right?
Yeah, I saw that how they retrieved their booster this week. That's crazy.
Yeah, watching them land is just like, wow, that is the man does a lot wrong, but the man does a lot right. Um, but yeah, it's pretty crazy. So here, I'm gonna get rid of my launch location here. And watch what I'm about to do here. So I'm gonna go into launch location and landing location. I'm gonna delete those, right? And then I'm actually gonna foreign key this twice to this table. I could theoretically make a many to many, but I don't want to add tables where I don't need them, right? So I can do is I'll do my foreign key here, my one to one, and I'm gonna call this um launch
Oh, yeah,
for
yeah.
that foreign key, and make another foreign key to the same table and make that landing. So I actually have the same table. These two, they're foreign keyed twice. But it's because it's two different values. I've got a launch location and a landing location. And then let's see. So we got that number of days, mission.
Then you need to do link the astronaut and the mission tables.
Yep. And so I got my many to many. Boom, boom. So we're at 1, 2, 3, 4, 5, 6, 7, 8. So I'm at 8 tables right now, and I haven't even gotten into mission control staff. I haven't gotten to company who's launching them. I haven't gotten into costs. I haven't got to payloads. So I'm at 8 tables. I could probably go into 20 tables in about 15 minutes really quick. And that's what I meant by saying if you get to between 7 and 10 tables or 8 and 10 tables, stop there because my next stop would be uh company for launching, mission control staff, um, payload,
A
blah blah
budget.
blah, budget. Yeah, I would. And then over on mission, there'd be like I'd add columns here, actual launch date, actual launch time, you know, plan, so I can explode from here, right?
But for
So
our final project, you said you wanted us to have like 7 to 10 tables, right?
yeah, 7 to 10 tables. If you hit between 7 and 10, stop there because if you go past that, I've had people who ended up with like 35 tables. That's just too much. Too much for you and too much for me to grade. But even with this, so here I've got these 7 tables, right? So I've got my multiple, I got my many to many tables. I've got my one to many. I've got a situation where I've got linking the same table to the one table twice. Um, uh, I haven't even gotten to crew assignment yet. I still need to make crew assignments, right? Um, so then what I would do is I would have a table. Let me finish that up. Crew assignment, crew position, and then position ID, and then name. And then what I would actually do is link it there because this astronaut had this group position on this mission.
Wow.
And I could even get creative and do this. Hey, let me do it. You're not going to let me do it. Oh, yeah, I can do it. And all three of the primary key because they'll never be duplicate. So the key takeaways for this is one, you saw how and I did it on purpose. At this point, when I make I don't add columns. I know where I'm going to go. I know what's going to be foreign keyed at. I wouldn't add the columns like mission and national. I would know that they'd be a different table. But for the purposes of demonstrating for you, Mark, and the 6 people who are going to watch this, and the 22 people who won't, um, I want you to see that you kind of take that first table and you list out everything you think you need to go there, and then you go through the normalization process.
And then okay, so you call it after you kind of,
Yep.
in other words, you talk your way through it.
Yep. That's what I do. And like you said, we talked before, but like, we're in the office, you're in a DBA team, you get that whiteboard out. I told you guys last time when I taught this class in person, my entire classroom, all the walls were whiteboards. So I would start in one corner and design the first table and write down everything I thought was supposed to be in that table. And then I'd look at it going, the table is astronaut. Does mission really belong in there? Right? Does that really belong in there? No, it doesn't because one astronaut goes on many missions and one mission has many astronauts and one astronaut will have many crew assignments. So I want to get all that stuff out there. So I'll just go down and say, this doesn't belong here. This goes on the table. This doesn't belong here. This doesn't belong here. This doesn't belong here. And I start building the tables from there. And then I've got to look at, how I'm going to put the data in the table. I showed you on the military rank table. A lot of people, I'm telling you, I will have people who in this class this year, this semester, will make a table for example, military branch, and they'll do military branch ID, Army, Navy, Air Force, Marines, Coast Guard, Space Force, and they will link that together. And that is not the correct way to do it. Because if you add another branch in the military, you've got to change the schema of the table. And we never, ever want to, unless we absolutely have to, we never want to change the schema to the table because it has to be something that we didn't expect. And the best example of this is when they were designed. So databases have been around on computers for a very, very long time. So probably like 90s, like late 80s, early 90s, there were databases on computers, right? So your employee table back in the day in the late 80s, you'd have name, address, phone number, maybe office number. You wouldn't have a cell phone number, and you certainly wouldn't have an email address. So their database, if you ever go into like a car dealership and watch like the repair center when they're typing in stuff to for the car repairs, their databases that they're using have existed since the early 80s.
Hmm.
And they're running on something called an AS400, which is this giant database appliance
Yeah,
that
DB2
if
from IBM. Yep.
yep, yep. And if you know how to do work one of those, you can make a lot of money right now. Like we're talking six figures out of college on an AS400. But those databases have existed pre-cell phone, pre-email address. So if I created a database back in the late early 90s and I had name, address, phone number, and that was it, I would need to add a column for email address because that didn't exist. And that is a definitive identifying characteristic of that column. I'd have to add cell phone, definitive identity request to that. There are other more politically volatile things I could talk about, but I'm not going to. So there are other things that we can change on these things because they didn't exist. We have to change them, but it can't be something that we could have foreseen. Was it likely they were going to make a new branch of the military? Probably not. Could they? Of course they could. And they did. It's so weird driving to the coast in Canaveral and seeing Space Force headquarters. It's just strange. Um, anyway, still not used to it. So when you are designing the tables, make sure that if like you're doing something like where something has color options and you have a color table, don't do a red column and a blue column and a green column, do a color column. That way you can add choices. If there's a size or a manufacturer or a producer or something like that, where you've got a number of things that have got to go in there, producer table, producer ID, producer name, and they're just rows of data in there. It's okay to have one table of foreign key. The same thing. You just need to change the names of the foreign keys so you know the difference. This is the launch one. This is the landing one, and it connects over here to the same locations table. So then I can look at this, and so I've done I've got my ERD. I've got 9 tables. I'm right spot on. I'm not going any further. I've got that. I want to make the code. I go here to databases. I go here to reverse engineer. I click next, next, next. And nope, that's what I do. I'm gonna do forward engineer. My bad. Forward engineer. That's fine. I don't want to skip the creation of anything. Export the tables. And there's my code.
And that's what you want us to give you so you can recreate our database on your side when you're creating it, right?
Yep.
Okay.
I want you to send me a screenshot of this. I want you to send me this code. I do not want you to send me the WMB files. I cannot open them. The version I use of MySQL is not the same you are using. I cannot open your WMB files on my computer. If you send them to me, I will just shake my head in sadness and then email you saying, "Can you send me the other thing?" Do not send the code to me in a PowerPoint slide. Send it to me in a file. This is a
I've been
screenshot.
in corporate world for 25 years. I've been having people send me a report in PowerPoint before. It's like, really, man?
I know, and I say this every year in this video, and I still get people who drop it into PowerPoint slide. Send this to me. So there's my code. I do copy it to clipboard, or I save it to file, and then I send that out. Okay, now, so I've got my ERD. Boom. I've got my code. Boom. Now, the next thing I'm going to do is I'm going to run my use cases first. So I'm going to look at my ERD and say, how would people use this data? The reason is if you do the use cases first, you'll know what data to populate for because you don't want to populate everything, just stuff that you're going to get responses when you run the use cases. So I might have a use case, which astronaut has been on the most missions and what were they? What was the most common destination in 2010? How many members of the Coast Guard have been astronauts? What is the lowest rank that's ever flown on a mission? What was the crew position of Bob Smith over his career as an astronaut? Um, how many launches in 2010 were late?
Ooh.
How many launches in 2010 were early? Were there any missions that had to come back early? So again, you can see all of these. How many launches were made from Cape Canaveral, Texas, Arizona, blah blah blah, you know? So you have, if you just start kind of like, snowballing, you can come up with 1,000 of things of how to get the data out, what people are going to ask questions of, you know. And then you just write those codes. You write the code, select from astronaut, where blah blah blah. Select uh Lincoln missionary, blah, do all the links you need to. And and the good thing is when you start pointing at these tables, it shows you how they're linked. I can say how many astronauts have launched from Canaveral because this is all linked. How many
How
astronauts
many
have
use cases do you guys want us to have in our final project?
5 to 7?
Okay.
5 to 7.
Okay, cool.
Yeah. So it's
And
it's
then
five
you
to
want us
seven.
to do the use cases first, so that way when we're populating the data, we're not focusing on, okay, yeah, okay, got it.
Yep. That way, if you have your use case written down and say, okay, I've got to put a couple rows here, I got to put rows here. You don't have to put rows everywhere. Also, and the final thing I'm going to say, because it's 10 to 11, I gotta go to sleep. I gotta get up at 4 o'clock in the morning. Um, when you're populating your database, go from the outside in.
Yep.
You can't populate mission first because you've got all these foreign keys.
Yep.
You got to populate a military branch, destination, location, military rank. You can populate astronaut,
To crew position.
crew position, then make all those, then you can link everything here together, right? So so just when you're doing this, you got to make sure that, yeah. So, yeah. So there you go. And
Okay,
that's how
cool.
you design a database. We'll probably do another one next week or week after next. One of the next 2 weeks is well, I'm going to go deep into indexes. I might go deeper into data types. I do like talking about them. I didn't talk about all of them. But I think that's it. Yeah. All right.
All right.
Any
You've
questions,
been
Mark?
very, no, you're good. You were very generous with your time. Thank you.
Oh, I love talking about this stuff. I haven't gotten dirty looks from my wife yet, so I'm okay. Um, so I'm safe. I'm gonna jump into bed here. So okay. Any questions? Talk to me. If not, I'll see you guys next Tuesday. Bye. Whoever's watching at home. Bye.
Thank you. Bye.